If entropy increases, why do patterns keep appearing in nature? Why do we see structure in storms, cells, ecosystems, and flowing water? Why do organized forms emerge at all? Many people hear the word entropy and immediately think that order should disappear everywhere, that everything should slowly become random, flat, and chaotic. But that is too simple. The real question is not whether entropy exists. It does. The real question is whether open systems can create or maintain local order while entropy still increases overall. And the answer appears to be yes. To understand this, we first need to understand what an open system is. An open system exchanges energy, and often matter, with its surroundings. A plant is an open system. A human body is an open system. The earth is an open system. A flame is an open system. Even weather systems are open systems. Because energy moves through them, open systems can remain far from equilibrium. And that matters. At equilibrium, gradients disappear. Differences flatten out. Nothing much happens. But many real systems are not at equilibrium. They are constantly being driven by incoming and outgoing flows. And when a system is driven far from equilibrium, structure can emerge. This is one of the most important ideas for understanding order in the real world. Take flowing water. As water moves, it does not only spread randomly. Under the right conditions, it forms streams, vortices, channels, and repeating patterns. Take a flame. A flame has a recognizable shape, but that shape is not static. It exists only because fuel enters, reactions occur, heat is released, and gases move outward. Take a storm. A hurricane is not a solid object, and yet it is a highly organized dynamic structure. Its order exists through continuous energy flow and instability. Take a living cell. A cell remains structured not because nothing changes, but because everything is changing in a regulated way. This is the key point. In open systems, order is often not a fixed object. It is a maintained pattern. It exists through throughput, through exchange, through transformation. This is where the idea of self-organization becomes important. Sometimes, when energy flows through matter under the right constraints, the system does not become featureless. It begins to organize. Patterns appear, structures repeat, stable behaviors emerge. This does not require intention. It does not require consciousness. It does not require magic. It means that under the right conditions, flow and constraint can produce form. Of course, this does not mean entropy disappears. Open systems do not escape thermodynamics. Local order still has a cost. Energy gradients are still consumed. Heat is still released. Entropy still increases in the broader picture. So we should not think of order and entropy as simple opposites. Instead, we should think more carefully. A driven open system can produce local structure while the larger thermodynamic process continues. That is not a contradiction. That is the point. And once we understand that, a deeper question opens up. What kinds of energy flow are most effective in creating or stabilizing order? Does direction matter? Does transformation matter? Does export matter? Are some forms of throughput more favorable for sustained organization than others? That is where my theory begins to move beyond the basic question. But the foundation is simple. Yes, open systems can create local order. Not by defeating entropy, not by stepping outside physics, but by operating under conditions where flow, imbalance, and constraint make organized patterns possible. Order is not always what happens when nothing changes. Sometimes, order is what happens when change is structured, and in open systems, that may be one of the deepest principles of all.